Hello everyone. Thank you for taking the time to review our senior project on process improvement at Poor Richards Press. I'm Charlie Kessiker.
And I'm Rebecca Farr. Today we'll be going over the following agenda. First, we'll talk a little bit about the company. Then Charlie and I will be sharing our problem statement, scope, and issues within the current state. After that, we'll summarize our findings from our research on the printing industry and close with our approach and objectives for moving forward.
Poor Richards Press, or PRP, is a general commercial printing company, meaning they print a wide variety of products, ranging from mugs to business cards to banners. Although they are very versatile and can handle most custom product designs, sales data indicates that over 80% of the company's profits come from in-house printing processes. We will therefore be focusing on these printing processes in our project rather than other product types such as embroidery or web design. PRP follows a make-to-order business model, so has a high-mix, low-volume product output. According to the president of Poor Richards Press, the company generally performs above industry standards when it comes to cycle times of their printing processes. However, from our initial Gemba walks and conversations with some of the higher-ups at PRP, we've learned that there is still a large amount of waste within these processes.
From these observations and confirming historical data, we have found that the average cycle times of the company's most critical printing processes do not meet the company's goal by 10%, costing them approximately $96,000 year to date.
Here is the process flow that every order must go through at PRP. The customer places an order, then it gets pre-flighted through the pre-media department. Once the job gets approved, it gets printed, then transformed into the final product in post-media. From there, it gets packaged and shipped to the customer.
Within this value stream, over 130 different processes can occur. After creating a Pareto chart from historical data from the company, we found that 4 printing processes, 2 post-media processes, and 2 shipping processes make up over 80% of their total costs. These 8 processes are the focus of our analysis and improvements. While this scope may seem large, our senior project team has enlisted another 2 teams of industrial engineers through the Systems Optimization Club. These teams will actually be assisting us in our data collection, and with this support, we hope to have the ability to take on more. Now, we'll be listing different issues that are specific to each of the 8 processes. These issues originate from our Gemba walks and conversations with the operators. We'll begin with the 4 printing processes listed here that are all different methods of applying ink to paper. At Digital, there is a major lack of formal, standardized training. New machines were purchased and no one was fully trained by the manufacturers. Also, a major amount of time is spent interacting with software in this department, and there is no optimized method of streamlining what the software achieves. At both the offset press and the mini press, the quality and type of materials can cause a major amount of downtime and underperformance. Most of the time, the machines will be slowed down due to paper thickness, warping, or ink type. At the mini press, reloading stock also causes downtime as this smaller press cannot hold large amounts for higher volume orders. For the large format printer, changeovers specifically related to a change in paper type cause large periods of downtime that are sometimes mechanically beyond the operator's knowledge.
For the trimming processes, the recurring problem that we have observed is the time lost from the need for reworks. For the stitch liner machine, we have observed operators begin a job that should have undergone additional processes prior, but they were not listed as requirements in the job ticket. The operator then has to fix the situation by moving all the work in progress back to the proper station to get the job back on track. Then set up the stitch liner all over again when the materials are finally ready. The packaging and shipping processes will be covered in the next slide because they don't really have a unique current state.
The following issues are actually universal to all aforementioned processes. These issues are largely systematic or related to human factors engineering. There is a lot of searching for materials, physically printed job tickets, or even the work in progress related to a job ticket. The operators will often go to the department before them to ask clarifying questions related to information that wasn't relayed on the job ticket. The company's method for logging work at each station isn't standardized, leading to sketchy data collection and lack of optimization. When a crisis erupts, there is no system for communicating and handling it. Some operators were observed wasting hours of time trying to fix a crisis on their own before going to their supervisor or moving on to a different order. Finally, at all workstations, operators could be seen bending or stretching to reach tools and materials in ways that may be uncomfortable or unsafe.
Through our academic research on past projects of similar nature, we've learned a couple of important lessons that we have kept in mind throughout the project. The first is that lean manufacturing can be very difficult to implement in the printing industry. One of the major barriers in implementing lean is the high-mix, low-volume nature of printing businesses. The wide variety and customization of jobs means that it's much harder to standardize processes and nail down sources of waste in the complex production environment. It's a lot like trying to hit a moving target. Another impeding factor that the literature has offered is employee resistance. Changing up the traditional way of thinking and doing things is something that most employees rarely want to do. However, at PRP, the culture of continuous change and improvement is fairly strong, and the workers are expected to be able to adapt to change if necessary.
While literature says that lean is difficult to implement in a commercial printing environment, other methods of process improvement have been implemented successfully. Employees at Hewlett-Packard wrote a paper on the usefulness of simulation and modeling-based design in visualizing and validating improvement efforts within their Palo Alto plant. Also, the printing industries of Southern Ohio partnered with other organizations within printing to encourage the benefits of process control charts and other defect-reducing tools. We recognize the benefits of simulation and plan on utilizing it later in our project. However, in order to maintain a manageable scope, we will not be looking into quality control.
For our project, we are following the DMAIC method. We have completed the define phase and will be continuing our measure and analyze phases until the end of the quarter. The improve stage outlines our design strategy, which revolves around facility redesign, ergonomics, lean and production activity control, and simulation. Facility redesign will help operators work more efficiently by reducing the required movement and motion, and workspace redesign and 5S implementation could allow for easier and quicker access to materials and equipment needed to get a job done. We will also be continuously assessing human factors and doing what we can to make the working environment as safe and ergonomically sound as possible. Keeping in mind the literature review, we plan to implement some lean manufacturing principles to minimize MUDA through systematic improvements. Finally, modeling the data that we collect and using simulation could give insight for improvements at each of the main processes, giving us a chance to visualize and validate improvements. The alternative solutions listed below were considered but were not pursued due to cost inefficiencies or impact on the project scope.
Thanks for your time. We can't wait to hear your feedback.